Hello, my distinguished students. You are once again welcome to our lesson series in Math 103. Today's lesson is titled Application of Algebra to Physical Problems. I hope you will enjoy the lessons as you go on. Thank you. You are welcome. Validated with the help of truth table. Thank you. You are welcome. As well known, my name is Dr. Adelwigwe Anjorin, Department of Mathematics, Faculty of Science, Lagos State University. At the end of this lesson, we should be able to 1. Recognize economic equations that appear as linear or quadratic. 2. Be able to solve this equation as earlier explained in previous lessons. Algebra has several applications to real life problems, some of which are expressible in economic terms. In this lesson, application to some economic problems will be given leading to both linear and quadratic equations. The method for arriving at solutions are already explained in previous lessons. Application. Consider a supply and demand analysis equation in economics. A demand function may be expressed algebraically as the expression in 1.01, where P is the demand function and Q is the quantity function. This is a linear equation relating demand and quantity supply Q. Similarly, you may also have quadratic form as the expression in 1.02 P equals Q squared minus 5Q plus 6. This can also be extended to revenue, costs, and profit functions. These are all algebraic functions. We denote total revenue by TR, which is equal to the price of the commodity times the quantity of the commodity provided. Total variable cost is also denoted by TVC, which is VC and is a function of quantity. Then the profit function is denoted by the difference between the total revenue and the total variable cost. The demand function is given as P equals Q A plus B. Then the total revenue, which is PQ, is quadratic. The profit function pi will now be the difference between the total revenue and the total variable cost, which is written in expression 1.07. This is also quadratic. Example. Given the demand function P equals 50 minus 2Q, express total revenue as a function of Q. B for what values of Q is TR equals to 0, and C what is the maximum value for TR. Solution. The total revenue given by TR is the product of the 500 minus 2Q times Q, would give us a quadratic equation. 500Q minus 2Q squared. When TR is equals to 0, you factorize the quadratic equation, and that gives you either Q is equals to 0 or Q is equals to 250. Q is equals to 0, no market situation exists. So you avoid such a situation. Then we pick when Q is equals to 250. Grammatically, this is explainable in the diagram as shown here. Then the total revenue maximum will now be equal to 31,250, as earlier stated in the above quadratic equation form. That is 500Q minus 2Q squared. The following activities are meant for you to practice for further understanding of this lesson. Given the demand function P equals to 20 plus Q, with fixed cost 4, variable cost per unit, variable cost per unit is 2. Obtain the function for total revenue and total cost for fixed and variable cost. What is the profit function pi? We also have these following activities which you can also further use for proper understanding of the course. Summary. Algebraic equations are applicable to many real-life problems. This problem exists both in science and arts. The case of economic situation is emphasized here for clarity. By now, we should have the good knowledge of how to interpret economic problems into algebraic equations and be able to solve them. We have some references you can also contact for further understanding and for further working on this particular topic. My distinguished students, I hope you really enjoy this lesson. If those problems in the activity are solved and those references are consulted, I hope you have more understanding of this lesson. Thank you and goodbye.